Welcome everyone. This is Codestar Night. We're going to do bytes and beats today. My name is Martin. I'm a front-end developer at Codestar. At Codestar we build functional reactive applications that scale, usually with Scala in the backend and TypeScript, React, Angular in the front-end. If you have any questions about what we do or in general about the building, just find the guys with Codestar posts. We're going to have a couple of talks for you today with two speakers. The first one is going to be Alex McClean. He has developed an application called Tidal Cycles. It's in Haskell, which is always great to see, something in a pure functional language. And he actually performs with it under the name Yaksu, and he does live coding and creates music that way. So we're very curious to see how it goes, especially in combination with Haskell. And yeah, that's about my talk. So we're going to go to actual talk from Alex. Give up an applause for Alex.
Hello, thanks Martin, and thanks for inviting me from Sheffield. It's great to be here in Utrecht. So yeah, I'm going to be talking about Tidal Cycles, this system that I've been making for about 10 years, with a bit of background into why I'm doing this strange thing, and some demos as well. So yeah, that's me in 2005 with my friends Adrian and Dave in a band called Slub. We actually formed this band in the year 2000 with the idea of making music just with our own software. So the idea was that we wanted to express ourselves with programming languages, which was quite a strange idea at the time. I think the idea of creative coding is quite well known now. You have maker spaces where people work creatively with code and other hardware and stuff. But in the year 2000, the idea of a programmer being a creative person wasn't really an idea at all. Programmers were people who just implemented stuff. So we had the idea that we felt that we could make music with our code, and we wanted to be on stage using our own software and sort of stand up for creative coding. Even though that wasn't a thing yet. But then, so at the start we were writing all our software and running it on stage with different strange interfaces. But around this time we started doing this live coding where I'm actually using Perl here. And I think this is something like a Lisp that Dave's using. It might be, I'm not sure. and Adrian was making his own strange programming languages as well. So we make our own systems and then go up and write the code live in front of the audience to make the music. To kind of push forward this idea of programmers being creative, because if you can see someone write code to make music in front of you and the music sounds okay, you can't actually deny that programmers are creative. And this has taken me to, I'm just trying to motivate why I do this thing. It's to kind of, I want to write code, that's what I enjoy doing, but I also want to collaborate with other people and code in social environments, because I enjoy working for hours at a time in the dark on my own, but after a while it gets quite lonely and it's nice to collaborate. I guess we have things like pair programming, but for me programming is really a solitary activity until you take it into creative collaboration. So this is me with my friend Kate. You can't see her screen, but she's actually dancing to a choreographic system that she's made in processing, sort of creative coding environment. So she's responding to a kind of choreographic notation, which is configuring itself. I should really have an image of this. And I'm live coding music. So this is an example where the body of the performer is really entering the stage as well as the body of the programmer. I could talk about that. That's quite a large project. I've also worked within a roots band and with lots of percussionists. Actually, this is me and my friend Matthew. So you can see my screen there. I'm writing code and running it, and I think there's like an acid line that I'm running there. And let's fast forward a bit. We're kind of working together as equals. So Matthew is playing the drums, I'm playing the Haskell, I suppose, tidal cycles. People are dancing to it as well. So whenever it flashes, that's when I'm evaluating that piece of code. So I guess that hopefully motivates things. It's kind of taking coding and bring it into kind of real time. So you're no longer writing code for someone else to run, but running code for the moment, for the people around you, your friends and other people in the room. And it's a very physical experience as well. Which is quite strange, because if I'm writing code that people are dancing to, I'm really in a state of creative flow, which is, sure the coders among you will be familiar with. You're kind of absorbed into this world of symbols and language, and yet you're also responding very physically to the mood in the room, the people moving in front of you, and also the sound itself, especially if you're on a stage with big subwoofers around you. It's not so much about what you code, but when you code it, it's really crucial to get the timing right. If you don't make a change for too long, the music loses energy, it gets boring. So you're continually making these changes, sort of developing the sound, sort of shaping the music. So the coding itself, the actual time when you do things, is actually part of the result, which is a bit different from normal coding, I think. So just a bit more background before I start getting into Tidal. So there was something in the air around this turn of the millennium. Lots of people were thinking, why don't we use programming languages to make live performance art? We started finding each other and formed a community. A meeting in Hamburg, we formed Top Lap, the temporary organisation for the promotion of live algorithm programming, and the manifesto and things that you can read about. But I think the most important part of this manifesto is that we really put forward the idea that we should show our screens. So it's kind of like a extreme open source free software thing where you're actually showing your screens while you're writing code, so people can see what you're doing. And the act of coding kind of becomes part of the performance. We just celebrated our 15th anniversary, had people streaming over 3.5 days from around the world. So this is really, since we met in Hamburg, 10 of us, there's now thousands of people around the world, and we have this stream where there was a different performance every half hour, streamed online from around the world, Chile, Brazil, States, Amsterdam, not so far away. And actually this is all archives if you want to see what other people are doing with live code. then you can look that up. So Algrave is a kind of word I came up with about, I don't know, when was it? Probably about 6-7 years ago. So this is really where we do this live coding, but with people dancing, like we saw earlier. It's like a dance party where people dance to algorithms. And this is a festival in the UK. And Algrave, it's like a global community, the idea is that we're trying to make something where something as ridiculous as algorithmic dance music, you don't take yourself too seriously. It's okay if you make mistakes. In fact, probably the biggest cheer of the night is when someone's code crashes or something. People, it's a supported environment. But it's spreading around, so not so much in Africa, unfortunately, but hopefully soon. But it's around the world. This is me and my friend Sam performing as class-compliant audio interfaces. Hopefully it's going to load. Okay. Let's find it. Oh, it's supposed to go HD. Okay. Let's try and find an interesting bit. So this is me and my friend Sam, who's playing a drum machine actually. That's what an Algrave sounds like, pretty much like any other techno party really, but everything's coming from code. I think it's interesting, just briefly, that Algrave and live coding has been covered in the media, and particularly in Wired, every 6 years is the new thing. Most recently, so 2006, 2013, hacking meets clubbing, DJs of the future don't speak, spin records they code. These are all articles, and I think it's interesting, it's always portrayed in the media as something sort of futuristic, but I actually think of it as being really retro. It's kind of stripping back user interfaces and using sort of the original interfaces, which is, terminals. But it's a kind of bit annoying really to be constantly, even though I've been doing this for nearly 20 years, still being covered as being the future, which we're really not. Anyway, so on to Tidal. So this is the system I've been making for about 10 years. The motivations are low latency creative feedback is the most important thing. You really want something that's responsive, immediately responsive. I'm just wondering how much time I've used actually. Yeah, it's okay. So I mentioned earlier that that earlier system I used to use Perl. There it is. The problem with that system is it might take a minute or two before I made any sound if I wanted to do something quite complicated. So a big motivation for Tidal, especially working with percussionists, is to have very immediate responses. So I can go from responses to, I used to take me a minute to make a change, but now it's like a few seconds, and that's really important. And that comes from the tersity of the language and the expressivity of the language. And another motivation is to discourage the wrong kind of error, like syntax errors and things like that, but also encourage the right kind of error. So as a creative system, I think it's important that you treat code as a material, so it's not just having an amazing piece of music in your head and typing it in, but much more trying something out, seeing what it sounds like, and then deciding what to do next in response. Much more like a creative search for something new and interesting, rather than sort of taking the role of a genius who just needs to get this fantastic composition out. It's much more of a collaboration, and I think that's what a lot of creative people think about their work, whether they're working with sculpture, It's not like having this kind of perfect vision in their head. It's much more about working with your material to find something that rises out of it. And in terms of inspiration, I thought I'd talk about 3 key inspirations. One is representation of tabla music, so Indian classical music, percussion. Something that's very symbolic. You see tabla musicians actually speak the drums with words, but it's also very cyclic, very rhythmic, and my music tends to be much more rhythmic than melodic actually. So this has been a really important inspiration. Another is musical patterns as transformation. So this partly comes from people like Laurie Spiegel, sort of electronic music sort of founder really, who she wrote this beautiful paper, Manipulations of Musical Patterns. I'll show you what I mean by manipulation of musical patterns. I also work a lot in textiles, and pattern from textiles is the same concept really. And functional reactive programming, which I now know that you do here. So I'll talk mainly about the third ones, but I'll briefly demonstrate the first 2 so you know what I'm talking about with Tidal. So Tidal has a MiniNotation for describing cyclic polyrhythmic sequences. What does that mean? So here's some very simple Perl code for, not Perl, let's say, Tidal code, Haskell code for demonstrating how that works. So this is plain Haskell. Pure 1 just means repeat the number 1 every cycle forever. And this is the MiniNotation version of that, so you just stick it in double quotes. If anyone has any questions at any point, just shout out, stick your hand up. You're very welcome to interrupt. This is how you would take 2 numbers and stick them together. You can see that. It's happening here, 1 and 2. And this is the MiniNotation for that. You can just stick them together into one sequence. So if I had, for example,
B, A, B, A, B.
So that's the equivalent with sound, it just repeats it forever. Actually that's a bit confusing, I'll use numbers.
0, 1, 0,
Yeah.
1, 0, 1, 2, 0, 1, 2, 0.
Notice it starts going faster the more numbers I add. So that's because there's no concept of a beat in Tidal, there's only a concept of a cycle. So when you add more things to a cycle, it has to make them go faster. Yes, so I can externally speed things up. So there's something equivalent to a BPM, cycles per second. But I can have more than one of these going, so I can have, and they'd be in sync.
2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2,
A, B, C, A, B, C, A, B, C, E, A, B, C, E, A.
So on. So you can also do things like take 2 sequences and play them at the same time with this MiniNotation. I have to make this a little bit bigger so you can see this second row. I think, yeah. And yeah, so it's just stacking up 2 sequences basically, which you can do with this code as well. You can also embed subsequences within subsequences. So here I've got 1 taking up half the cycle, and then for the second half I've got 3 events, 2, this one, and then 5, and this event is broken down into 2. So we can listen to that if you want. How's it numbers? 10. So that is now a pattern of
1,
sound.
2, 3, 1, 2, 3, 1, 2, 3, 1.
You can also do things like just play this 12 times, or you can do that with a substance as well. And you can also, if I put a question mark here, it will drop them out randomly. So I could do that with just a kick drum. So there's different ways of just introducing a bit of random variation there, if you want to. So that's a slightly more complex thing I was doing on the train, it seems. So basically, already, just with the sequence notation, you can do quite complex things. Yeah. Right, so the second thing is musical patterns as transformation. Oh, sorry, there's a question there.
Yeah, what was the star in the notation?
The star just means speed it up. So you can read it as play it 12 times. But what it's really doing is, just saying play it 12 times really fast. So yeah, it's just speeding up time.
And do you have like a pause notation?
Pause, yeah, so like a gap. Yeah, so that's just like a rest in musical language. There's quite a bit more in here, but that gives you an idea about the kind of things you can do without even writing any Haskell code, really, just this MiniNotation. And actually Haskell people really hate this, because it's not really safe. I mean, yeah, it's not type checked, that's the word. But I don't know. Yes?
What happens if you make a mistake?
What happens if I make a mistake, and that was the question. So if I had that, it would just come up with a kind of syntax error in the parser and cause an exception, which isn't a disaster because the sound would keep going. It wouldn't stop it, wouldn't make it crash, it would just carry on until I fixed it. So yeah, I don't know. I was quite surprised that Haskell people hate it so much, but there is something called template Haskell, which apparently you can fix, make that type safe, but it wouldn't actually make it any more usable. So. Are there any Haskell people in the audience, by the way? Sorry. Do you hate this? Do you find it strange that I have a parser within?
Makes total sense.
Okay, good, right. I just need to explain it, it's all fine. Good. Right, so then I was talking about pattern transformation. So it has a library of combinators for transforming these sequences. Although as we'll find out later, they're not sequences. But I mean, one thing you can do to start with is just like arithmetic. So I can add 1 and 2 to 3 and get 4 and 5. If that makes sense. So it's just taking that pattern and adding 3 to both of those. I can also do that. So 1 is added to 3 and 2 is added to 4 to get 4, 6. That makes sense. Then what happens if you add things of different structures? This is something that's been changing lately in Tidal, actually. I've kind of rethought this. But if you run this now, what you get is this. So the 1 still gets added to 3, so you get the 4 here, and the 2 still gets added to 5, so you get 7, but then the 4 gets split in 2, and so you end up with half of 4 being added to the 1 and half being added to 2. That's not always what you want to happen. So there's 2 other forms of addition. One takes the kind of structure from the left and one takes the structure from the right. So this one, if I add 1 1, 2, 3, 4, 5. It keeps the structure from the 1 and 2. So now this 4, from 1 being added to 3, is here. But actually only 2/3 of it is active. So you've lost the end of it. And the same, the 4 is being added to 1 to make 5. The structure's coming from the left-hand side, so it looks like this, but you've lost the start of it. This is pretty strange, I guess, but and if I run this, if I take the structure from the left, I still end up with 4 events, but it's this that gets split into, and you only end up with half an event here and half an event here. Yeah, maybe that makes some sense, but I think it's something you could only really get a feel for the usefulness of this if you actually work with Tidal for a little while. But if I try to play this,
2 1 1 2 1 1 2 1 1 2 1 1 2 1 1 2 1.
Done that wrong. Okay.
7 4 5 7 4 5 7 4 5 7 4.
You only hear 7, 4, and 5 because this one hasn't got a start, so it never actually begins making sound. Yeah, that's a strange thing. But then if you add that to something else, this becomes useful again. Let's see. Yeah, so this addition makes sense for things like transposition, so I can go up 12 notes here, or 7 notes to go up a fifth. Or I can do this, which will pick one of these every cycle. It always finds a way to add them together. So this is a very declarative system. You don't say how exactly these are added. You might give it some hints, but you just say add this to this and it works it out for you. Right, so that's arithmetic, I guess, is one kind of way of transforming things by composing them together. But there are a lot of other things for manipulating sound. So if I just start with a simple sequence. So if I use iter, that would shift the sequence quarter of a step every cycle. Can you kind of hear that? It's kind of shifting it along 4 times so it gets back to where it started. So that's quite a lot of rhythmic variety already. I could also use chunk to do something similar. So this is every cycle it shifts along by a quarter and just applies this function to that quarter. And hurry is basically speeding up both the playback rate of the sound and the playback rate of the pattern. If I do jux rev, if I rev it, it'll just play it backwards. If I do jux rev, it'll reverse it only one speaker. So now we've got a stereo effect where there's a function being applied to one of the speakers. Yeah, we've just spent a long time getting stereo working. Know why I did that. And there's a lot of those. I'll do more of a demo later. But now you can kind of see the whole of Tidal exists as kind of quick way of making a sequence and then ways of transforming that in different ways. So the third, yes, please.
There are predefined kits or sample kits in it, or can you load your own samples on?
Yes, so by default, Tidal comes with a bunch of samples. So it comes with loads of samples, and for example, inside, what was I using? CPU1. Actually, that's one of mine that doesn't come with Tidal, but we'll look anyway, see what there is. Oh, it's not there. Okay, let's look in Casio instead. That's got 3 different sounds in. So when I do D1 sound Casio, you might. I can play those 3 sounds like that. And you can add more WAV files. But it can also play synths, so it's got a bunch of. So that's not samples, that's synthesis. And you can also pattern different effects and things. So it's quite a fully featured synthesis engine running in this language called SuperClider. Right, so anyone? Oh yeah, go on.
So you've shown quite a lot of ways to produce some patterns. Have you experimented with recursion and maybe fractals? Maybe
yeah,
it's too complex.
it's not possible. I'll tell you why that's not possible. Actually, there is some fractal stuff there, but it's kind of not in Tidal itself. So, why I can't really do fractals in Tidal? It's because it's functional reactive programming. Yeah, I'll come to answer that properly later. But Tidal isn't about manipulating data. When I run rev, I'm not reversing anything. I'm changing the behavior of the function by wrapping it in something else. And this is the type structure. I realise that there are only a few Haskell people in the room, but I can talk through this, it's fine, don't worry, it's all going to be fine. That's. So the first, this has taken me 10 years to write, by the way, and at some point it was really long, and it just keeps getting shorter. But I'm pretty happy with it as it is now. But I'll step through this. So the first one is time is rational, which basically means time isn't represented by a single number, but 2 numbers, one divided by the other. So you can represent a third, which you can't normally do in floating point mathematics, which programming languages generally use. So there's no floating point errors. It's great for subdivisions, which music has loads of, unless it's techno, which I don't really know, but never mind. And also, each integer along this rational timeline signals the start of a rhythmic cycle. So 0, 1, 2, 3, this is kind of counting out something like a musical bar, and everything else is just a subdivision of those bars. So times kind of has this notion of being cyclic, although it does progress over time as well. So the next one's quite simple as well. A time span is 2 times, so it has a start time and a stop time. It's just a span of time. And we actually call it an arc in Tidal because of this notion of it being cyclic, but I think time span is a bit more readily understandable. So time span is just a start and a stop. A musical event is also fairly simple. It's a bit confusing because it's got 2 time spans, but the most important one is this part. So an event has a time span and a value. So that value is active during this time span. The reason why there's a hole there as well isn't super important, but it's to do with being able to represent fragments of events. And also there's a maybe there, which lets you represent continuous events, so things like sine waves. This is something quite nice about Tidal, I think. You can, in the same representation, you represent both continuous events like sine waves perfectly, as well as discontinuous events like notes that have starts and stops. Yeah, I can talk about that afterwards over a beer maybe. And this is the final bit of the puzzle. So a pattern, what this means is that it's a function. That's what this is. The input of the function is a time span, and the output of the function is a list of events. So a pattern is a function from time to events. Nice and simple. Maybe, does that make sense? So a pattern is a function from a time span to a list of events taking place during that time span. So remember that event has its own time span. So this is like saying what is happening here, and then in response the pattern says these things are happening at these times during that time span that you asked for. That is all together. So the disadvantage is that there's no temporal state. So that means no Markov chains, no L systems, which is a kind of fractal. You can't do anything which does some calculation based on the step before. Otherwise, because to do that, you'd have to call another function, which would then have to call another function back to the beginning of time, which would be really inefficient. So that's a big disadvantage. There's certain things you can't do there. Although Tidal does have both these things, he basically generates a list and then turns that into a function, so it's cheating really. Another problem with this is that it's kind of difficult to predict as a programmer. It's not too good for transcribing existing music or music in your head because it's quite a strange representation. You never really have a sequence, you just have a function that's kind of opaque. And there's probably other reasons why it's difficult to predict what's going to happen. It's just all this composition is hard to know what happens in the end. But these are also advantages. So no temporal state means that time can be manipulated freely. So you can time travel. You can't do a calculation based on a previous step, but you can shift time so that it becomes the present. But you're then dealing with what would have happened, not what did happen. So you can't do that Markov chain thing. But yeah, I can explain what a Markov chain is later as well if you want, over the same bit. And it's also random access. It's good for live coding. There's no state, so you can just replace all the code. There's no state to worry about. You just continue on with a new bit of code. So it's also highly composable. It's really easy to join functions together. You don't have to do any calculation. You don't have to deal with data. There's no lazy list, but it's still lazy. There's no you don't actually calculate any data until it comes to sequencing it, scheduling it, sending it towards the synthesizer. And as I said earlier, it works with both discrete sequences and continuous signals. Does that make sense? But if you've got a function, I mean, it's easy to think about how you reverse a sequence, but how do you reverse a function? Or how can you make this?
Would that be a good reason to do Lisp, for instance?
Would that be a good reason to do Lisp? Would what be a good reason to do Lisp?
No, but you can manipulate functions in Lisp because they're just ASTs, basically.
Right, okay, yes. Yes, why isn't everything an AST that you can manipulate? The MiniNotation does create an AST, and I've been thinking of turning the whole of Tidal into some AST thing. Yeah, it's an interesting question. Yeah, it would be possible in Haskell too, but I haven't done it yet. I think it would take some copies. Yeah.
Maybe something similar to Parsec.
Sorry, what's that about?
Something
Parsec?
similar to Parsec.
The MiniNotation is using Parsec.
Right.
Pass, yeah. Right, so how do you manipulate a function? So you can't change a function, but you can make a new one that manipulates values passed to and from it. So if I had a function that was just a voice saying 1, 2, and I wanted to make it faster, when that time span came in, I just multiply it by 2, and then I get twice the number of results out, because I'm asking for a bigger time span. And then when it came out of that, I would take the result time of the events and divide it by 2. And then the result would come out faster. Does that make sense? It's kind of manipulating time in both directions. So that's how it goes from this. So that is wrapping this function in a new function that just manipulates time. And this is underscore fast because there's another thing which then turns the function from time to a pattern of time. I can demonstrate what I mean by that. So if I take that and so the parameter to fast is itself a pattern. So let's make this a bit more. So almost everything in Tidal is a pattern. So you can, manipulating this pattern with this function, but its second parameter is also a pattern. So there's all kinds of patterns going on. And I could even make that faster. I don't know what that would do. Yeah, after a while it's hard to know exactly what's going on. But you can see how everything is a pattern, and yeah, it's patterns all the way down. Right, so are there any questions about Tidal and function actually? Yes.
Yeah, can you change the gain of the volume of the sound?
Yeah. So,
Can you repeat the question?
Yeah, I'm sorry, but the batteries on this thing are running out. So
Oh,
if you could
okay.
just repeat the questions for the recording.
yes, so the question was, can I change the volume, the gain of the pattern to kind of mix it? And so that's just another pattern. So I can, I can use a continuous pattern to let me think. Okay. So I like to do mixing with just filtering instead. So I can just take out the lower frequencies or the upper frequencies. Right. I can also do things like every third repetition, make it slower. So there's lots of kind of higher order stuff going on here. So this is a function that takes a function as input, and it applies to this conditionally every third repetition. Okay. So shall I do a bit more of a demo then of what is possible? What was I doing on the train? So I can start with simple melody, of course. I can sort of make it. So if I take that and every 2 repetitions, if I add whoops. So now every 2 repetitions I'm adding one pattern to another, just to create a bit more variety. If I offset by a quarter of a cycle and add 12, then it'll go up an octave. It'll keep the original one there, but it'll add another version of it on top, offset in time, and also offset by going. But yeah, you kind of get the idea just by adding these simple transformations on top of each other. It starts, all these sort of interactions sort of appear. The interesting thing about this is it's kind of in, it's kind of 3 beats to the bar here, but then I'm doing other things which treat it as if it was 4/4, so you kind of get this sort of polymetric thing happening. So if I added a drum beat on top of that, like this, that was 4/4. At least I hear, I don't know about you, but if you should go from 4/4 to 3/4, you quickly, the whole character of it shifts, even though I'm changing this completely separate pattern. That's 3/4. So you're kind of dealing with your perception and sort of exploring this music. What you hear isn't really on the screen or in the code, but it's what you hear. Yeah.
You were saying earlier that it was getting a bit messy.
Yeah.
I was wondering if you make a pattern or manipulate it in an extractive method or break it up in some way? I'm not familiar with that word.
Yeah, so the question was, how do you deal with it getting messy? I mean, I tend to use this as a performance tool, so there's no time to sort of deal with abstraction. I mean, I could give things names and things, but when I said messy, I kind of meant musically actually. But yeah, I mean, there's ways of having shared variables and things and giving things names. But there's just no time for abstraction in a musical performance. So the usual kind of, once it gets too messy, basically throw it away and start something new, so it's all fine. Okay, I think I've got time for another quick thing. So, I'll deal with some longer samples this time. So, start with the same kind of melody. So this is called a Euclidean rhythm, where you say play 3 steps over 8. Just play on so it distributes 3 sounds over 8 steps, which isn't possible evenly, so you get this kind of off-kilter rhythm. Just a really quick way of making a rhythm. I can offset these as well. That's a bit more variety. And do this thing where I'm taking the original, keeping it there, adding a copy on top, shifted in time, with 7 added. We'll do that again, offset by an 8th this time. And an octave. I do Jux Rev a lot, so if you want a drinking game, then drink whenever you see Jux Rev. So let's deal with the longer sample. So this is MIA. So I've got this longer sample that's chopped into 16 bits, so if I just reverse that. Get the idea.
final questions? Plenty of questions. How much of this is intuition?
So these two things are sort of set pieces that I do. But I'm most happy when I'm just improvising freely, which I do more easily when I'm collaborating, because it's I mean, there's less pressure because you're only making half the sound, or maybe less. And then I much more enjoy sort of just trying things out and sort of exploring, which has a certain amount of structure to a performance then, because you get these parts where not much is happening, where you're just trying things out, and then things sort of come together and you just follow it somewhere interesting, and eventually get bored of it and go back down again. So you get this kind of undulating sort of structure without any sudden changes often, which is why it's nice to play with instrumentalists and you get more immediate reaction. But yeah, I'd say a lot of it is sort of intuition or more kind of responding, improvisation I guess is the word I'd use. Intuition is a funny one, isn't it? It kind of implies that you have something inside you which is guiding you, whereas I think it's much more a sort of feedback loop between you and the code and the sound.
All right, so I was just wondering, in your third channel, I think there's splice 8 iter 4, but you didn't close that. Is that now not being run, or is that like, how is this being parsed? Is it being cancelled out? What does it do now?
Yeah, so that was here. So this splice 8, you're saying that's not being closed?
Oh, all right, yeah, it's in there.
Yeah, okay.
I understand now, but like, if you had an error like that, would that entire thing just keep running and you wouldn't hear it? Is there any feedback you get in the sense there?
It's Emacs. So yeah, if I'd forgotten this there, yeah, you just get possibly incorrect indentation or mismatched brackets. Haskell isn't great at error messages. There's no context in it. I mean, I don't know why it hasn't at least told me asked if it has, but yeah, I guess when I'm performing live, I'm doing things that are simple enough where I don't tend to make mistakes. And if I don't immediately see a problem, I'll just delete it.
But if it were broken while you were playing it just now, you wouldn't have noticed that the changes weren't coming along, or
yeah,
it would keep playing the original one.
Yeah, just carry on. So yeah, there have been times where I've been editing a bit of code and not realised that there's been a syntax error actually. Yeah, I've actually made a new text editor in Haskell which does tell you when something's broken at least, but then you don't get any error messages at all. Yeah, I think the area of live coding text editors has a lot of mileage in it actually. I have one really strange system called which is texture, which is like a visual environment for the Tidal. See if I can find it. The Scottish Weekly board. And this is nice because you can't make syntax errors. So it just connects things up based on proximity, and it won't connect up if it doesn't type check. So things which are type compatible and proximal connect. I don't know why it's not making any sound, probably. Oh yeah. So I think maybe the way forward for live coding is these weird kind of text editors where there's a lot more feedback, so you can actually see the patterns go between the functions, with currying and things somehow represented. Partial application. Yeah, future, I don't know. It gets pretty out of control pretty quickly. But,
Now we just have to solve the cell phone problem before you can make music.
So yeah. Oh no, now you see all my YouTube suggestions. Yeah.
How do you sync up to laptops?
So that's an interesting question. How do you sync to your laptop? So there's different ways of doing it. One is when my friend's using drum machine, we just use MIDI clock. If I'm playing with a friend with Tidal, we'd probably use something called Ableton Link, which is like a standard way of syncing things. Or there is something called Troop, which is a collaborative editor like Google Docs or something, made by this guy, Ryan, for his Foxtrot system, which is similar to Tidal but written in Python, but he's also made it work with yeah, he's also made it work with Tidal, but this is Foxtrot, which is Python actually. And the sound actually only comes out of one laptop, so because you're both using the same editor. Well, it can come out of both, like if you're in different parts of the world, then you can jam over the network. Yeah. But yeah, there's bands who use this kind of system. Yeah, network music is like a whole research field. That's quite nice. It's more relaxing than usual thing. Yeah. And you can edit each other's code, and yes, it's a really nice way of collaborating. They don't seem to be editing each other's code actually. Oh, here maybe a bit more. You can kind of see the different colours in comparison. Yeah, Foxtrot's awesome. So yeah, standard things like Ableton Link or weird text editors again. So, yeah.
Do you have some background in music?
Well, I've been doing this for 20 years, so yeah, but before that, so my background is, yeah, I've grown up making music with code, I guess. But yeah, I don't have any training in music. Ryan does, so his system has much more stuff in it about melody and things which I don't know about, but yeah, I've grown up listening to sort of IDM and strange music and just sort of, yeah, practice-based exploration, I guess.
What is the size of the sound library you use?
The default one, yeah, since like the default samples, there's probably about 100 different sound banks in there, each with quite a few samples, which was just the contents of my hard drive when I started developing Tidal about 10 years ago. But when it actually comes to perform, I've probably only got maybe 5 or 6 sound banks in my head that I want to use, although I might go outside of that. I guess it's nice to kind of creatively constrain yourself with sounds. Yeah, there's also quite a lot of synths in SuperDirt now, probably about 20 different, it's sort of growing all the time. So it's quite a nice palette of sounds. But once you start kind of taking a sound, even like a really simple clap sound, and then chopping it into bits and sort of doing this kind of thing, it can get to the point where you're making new sounds just by manipulating them in Tidal. I guess that gets towards something called granular synthesis, where you're taking sounds and using them as source material, but then actually manipulating them to the point where you're almost synthesizing new sounds. That answers your question.
More questions?
That's a great discussion.
Yeah, so have you ever combined this with some kind of live expression like you get with, for instance, rock and roll bands or in drum and bass, the whoop whoop, I don't know what it's called, where you really have some kind of reaction based on something that you do live?
Yeah, when I'm performing now, I have a MIDI controller where I can change things like filtering and stuff, adding reverb and stuff like that. So, I mean, this is actually a slight simplification. This pattern, this time span, there's actually, it's a bit more complicated. You can pass in state from an external device or from a shared variable or something. So actually you can have input into a pattern. And I use that for basically doing simple filtering. Beyond that, I find it too much to think about. I really want to focus on the code and maybe just adjust the mix a bit by tweaking some filters. And if I want, and it's through collaboration and get that more kind of immediate sort of hands-on expression. I think working with code is just such a different domain from gesture. It's hard to imagine sort of with one hand making a sound and with the other typing code. It's quite a mental shift from one place to the other. But maybe, I don't know, maybe you just haven't got the right interfaces for it yet. Maybe that'll happen in the future. Because if you think about it, like the human voice is like a really nice instrument because you can express words, symbols, and also gestures. And our brains are really good at lateralizing this and sort of absorbing these different channels of information. And when it comes to code, it's just all about the symbols. So maybe there is a way of integrating gesture more into code, but I don't know, I haven't found it yet. I'm just going to give more and more abstract answers.
Thank you very much for your talk again.
Thank you.